Hi friends, have you ever thought which is the best cooking oil, especially in an Indian scenario? We have so many different oils, including ghee, sunflower oil, mustard oil, groundnut oil, coconut oil, sesame oil, and so many different varieties and so many different cuisines across the length and breadth of the country. But which one of this is the best one? How do they impact your lipid profile, including your LDL levels, triglyceride levels, VLDL levels, HDL levels, which are cardioprotective and which push you towards heart disease? Is there a correlation between dietary fat and fat that is circulating in your veins? I'm here to tell you there is. There are certain oils which will increase your LDL levels and certain oils which will make you resistant to heart disease. Today, I'm going to debunk all the myths behind oils used for Indian cooking, especially the one that sunflower oil is the most healthiest for you, because it's not. This is a very vital question. Whether you're young or old, you need to know the answer to this. So stick around to the end of the video to find the verdict on which is the best cooking oil in the Indian scenario. Let's dive straight in to the session. Welcome to Health and Nutrition with Sabyasachi. Alright, so today we are going to study about lipids which are coming from food, that is exogenous fats, and we'll realize that they are far more than just fats. So let's dive right in. There are so many different types of fats. We also call them oils. There is, especially in the Indian setting, there is ghee, there are seed oils, there is groundnut oil, rice bran oil, olive oil, and so much more. And when you look at the lipid profile, interestingly, you don't see the levels of seed oils or ghee, right? What you actually see is the levels of your cholesterol, which is LDL-C, HDL, etc. Then you see levels of triglycerides and a few other parameters. Essentially, what we are trying to understand is how do these merge with each other? So what does consuming excess of ghee cause to the lipid profile, or what does consuming a lot of seed oils on a daily basis cause or change the lipid profile? That's pretty much what we're trying to understand today. As we know, these have a lot of bearings because some types of oil will keep pushing your cholesterol up. And what we want is to bring it back down. And then we also want oils which will increase your levels of HDL cholesterol. So we want oils which will reduce your LDL cholesterol and increase your HDL cholesterol. And that's what makes them cardioprotective, in a sense. Imagine these are blood vessels, and these really small dots of white are the lipids which are floating around. That is lipoproteins, that is your LDL and triglycerides. And imagine then going and eating a fried food. It could be fried chicken or it could be fried anything else. You have to visualize that the amount of fat in your circulation is going to increase, that you can see on the bottom left of your picture. When that happens, all these circulating fats are really going to go and accumulate into the blood vessels. So whenever you're having an extra samosa or some extra fried food or maybe a lot of chips, this is what you need to envision. This is what might be happening in your blood vessels. All that yellow thing are all these cholesterols, and that is causing the inner half of the blood vessels or inner side of the blood vessels called the lumen to become roughened up. All of these blood cells, that is platelets and red blood cells, will start accumulating, adhering there, and this lumen will close. Your blood vessel will get obstructed, and that is when a lot of disaster can strike. If this blood vessel is in the heart, it can lead to a heart attack. If it's in the brain, it could lead to a stroke, that is paralysis, right? So eating that extra samosa or some of those foodstuffs that we love can have consequences, and we are trying to understand how we can mitigate some of them. So in the Indian context, the other question is which cooking oil is best? We have high heat cooking. So which is the best cooking oil amongst the different ones that we have? Really, we are asking is it okay for high heat cooking? So what is the boiling point of that oil? And the oil which will have minimum influence on your lipid profile, minimum cardiovascular risk, minimum fatty liver risk, your waistline, your weight control, and all of these things, right? So in the Indian context and generally in the global context, if you take out the point number one, we want to look at oils which are the best for all of these. Which oil you use for cooking is as important as which protein you consume. And this question is going to remain vital throughout life, from your teenage years till you're very old. This is vital to understand for children, for grandparents, for adults, for adolescents, for everybody. So this is an extremely vital question, and I hope that you are going to stick through to the end of the lecture. Remember that I am not a dietitian. I am a medical doctor, but I have not specialized in nutrition or physical training. So whatever I'm trying to say here is not considered medical advice. Right? So a quick disclaimer before we go through. But who I am is I am an eye specialist. I am a trained doctor, and I am especially a vitreoretinal surgeon, and I practice at Future Vision Eye Care in Mumbai, that's in Borivali East. And all of you are welcome to come and visit me, and we can talk over it. So the whole video has timestamps at the bottom, as if you see, but I would urge that when you're watching this for the first time, you watch it in the same sequence. When you're coming back later on, you can go to the section on saturated fats, on unsaturated fats, on omega-3 and all of those. But for now, I think I hope that all of you are going to stick through the timeline one after the other. This is really a continuation of the previous session on your lipid profiles, where I discussed. So this is all about endogenous lipid. You can find a link for this in the description below. So in this session I talked about ApoB levels, LDL cholesterol levels, and how you interpret your lab reports, that is your LDL, triglycerides, and all of those. And so I urge you to watch this as well if you haven't done so. So this is the real slide which was the backbone of the entire previous session. Here what I have shown you is what happens when you are consuming glucose. Glucose really gets converted into something called acetyl-CoA, which is then passed on to formation of ATP. ATP is adenosine triphosphate, which is the energy molecule in our bodies. But when this acetyl-CoA is high, when you are consuming too much of carbohydrates, too much of glucose, acetyl-CoA, is not then necessary, because we are not even doing any exercises and other things, right? So our ATP requirements are low, whereas our glucose consumption is high. That leads to too much of acetyl-CoA, which then gets pushed towards formation of cholesterol. So the liver can form cholesterol on itself. Even if you don't consume cholesterol, then acetyl-CoA can also get diverted into fatty acid formation and then triglycerides. And what the liver then does is combines these triglycerides and cholesterol together in a molecule called VLDL, which is very low density lipoproteins. This then combines with something called ApoB100, and that's released in circulation. In circulation, the VLDL drops the triglycerides to the cells for energy purposes, and then only carries the LDL-C. The triglycerides can be burned for energy, right? Even in the cells, this is what is happening. Triglycerides then can get converted into acetyl-CoA and then ATP. But again, if there is excess of this, what happens is these triglycerides are taken up by fat cells, which are called adipose tissues, which are present inside, in your tummy region, and also inside around the viscera, around the organs. And all this excess in circulation, after the adipose tissue is soaked up, it then again goes back to the liver, and then it gets converted to triglycerides, and it's going over and over in circulation. Too much of triglyceride accumulation in the liver, along with too much of cholesterol accumulation in the liver, then leads to fatty liver, right? So this is pretty much what we have seen in the previous session. The LDL cholesterol is actually transported inside cells. This LDL cholesterol is then cholesterol is extracted, and it is utilized for many different functions, like formation of hormones and formation of the cell wall, and functioning of the neural cells in the brain and many other places. The free cholesterol on these cells is then taken up and gets converted into a form called HDL, and that is then transported back to the liver, right, and gets formed into cholesterol again. Now if there is too much cholesterol in circulation, that is LDL cholesterol in circulation, it doesn't enter into the cells. What happens is then it goes back and the liver reabsorbs it using LDL-C receptors, and then recycles that as well. So this is pretty much what is happening when you are consuming a lot of glucose. What we are talking about today is dietary fat, right? So what happens to dietary fat, right? So remember, if you are consuming excess of glucose, then what happens to dietary fat is it is going to go into cholesterol formation, into fatty acid formation, and it is not going towards ATP formation. That's because glucose is already producing acetyl-CoA and ATP. So to get the dietary fatty acid towards ATP, so the dietary fatty acid can go towards triglycerides and then through this cycle into ATP, or it can go towards cholesterol formation. Cholesterol is hardly broken down into acetyl-CoA ever. So dietary fat, we want to push it towards this and then towards this, and not towards this. For that, you have to be in a glucose deficient state, right? If you're continuously consuming glucose, this is not going to happen. So once glucose has dried up, once there is not much glucose, that's when dietary fats will start coming into the picture. So from henceforth, whatever we're going to talk is in people or in individuals who are not consuming a lot of carbohydrates, or essentially those who are in low carb states, and those who don't have insulin resistance. If you don't know what insulin resistance is, you can watch some of my previous videos. The links are all in the description, right? So, this is pretty much the setting where we are at present. So dietary fat, we want it to go towards ATP production, and we do not want it to go towards triglyceride and cholesterol formation, right? So that is pretty much what we want to do. So, which are the oils which go towards ATP formation and which are the oils which push us more towards cholesterol formation is what we are trying to understand here. So the oils that we consume, small chain, moderate chain or medium chain, and then long chain fatty acids. 90% of what we consume as fats from oils and many other things are long chain fatty acids, and that's what we are really going to see today, because that's pretty much what impacts our lipid profiles and our health overall. So what is the structure? The majority of the fat that we eat, like I already told you, is in the form of triglycerides, right? You've heard this before. We were talking about endogenous production, but whatever we eat are also triglycerides, right? So the structure is triglyceride. Glyceride is the backbone, or glycerol is the backbone. It's the form of alcohol which can be burnt into, making ATP. And then we have 3 fatty acids, right? So triglyceride, 3 fatty acids and the glycerol backbone, right? So now this glycerol and fatty acids are bound to each other by double bonds. So the structure, and it's important to understand this, you will realize why, is because in saturated fatty acids, there is only one double bond between this glycerol and this fatty acid chain. There's only one double bond. That's what makes it saturated. That's what keeps it solid, and they are all densely packed. And there is not much space among that. So saturated fatty acids, or SFAs, are predominantly solids, right? They could also be slightly liquid in room temperature, but a lot of it is going to be solid or semi-solid. So if you think about it, you will realize that what we're talking about is ghee. Ghee is the prime example of saturated fatty acids. The next is unsaturated fatty acids. That means they have more than one double bond. If they have only one additional double bond, we call them monounsaturated. Mono, that means there is this additional, if you see this is a single bond, here there is a double bond. So there is one extra double bond here, right? So this is what the body has to break. Body has to break double bonds to use this for ATP or for anything else, right? So to break monounsaturated fatty acids, the body has to work more. To break saturated fats, the body has to work slightly less. So in monounsaturated fatty acids, one additional double bond, will lead to a bit of kinking. And these are called monounsaturated fatty acids, or MUFA, and they are predominantly in liquid form, right? That's because there is some space, and those double bonds help it to become a little bit kinky, right? So you get it in form of liquid. And if there are more than 2 double bonds, we call them polyunsaturated fatty acids. As you can see, the initial double bond is there is another double bond, and then there is another double bond, right? So then what this makes it is much more liquidy or free flowing, right? So polyunsaturated fatty acids are completely liquid. Monounsaturated fatty acids are also liquid but slightly thicker and or more viscous, let's call it. And saturated fatty acids are essentially solids or semi-solids at room temperature, especially in the Indian scenario, right? So this is how structure of dietary fat is constituted. Right, so these are PUFA. So overall, the summary is saturated fatty acids, there are no double bonds. It's a straight shape. It's solid at room temperature. Examples I already told you is ghee, meat, and butter. Right? So all animal fat falls under the saturated fatty acids. MUFA is monounsaturated fatty acid. It has one double bond. It has slightly bent shape, and it is therefore liquid. Examples are olive oil, nuts, and plenty of others that we will see. PUFA is polyunsaturated fatty acid, that is 2 or more bonds, and therefore it's more bent, right? And therefore it is more liquid at room temperatures, like sunflower oil or other seed oils. And there are others called trans fats, which are of course artificially bonded together. They are straight, but they are not natural, and they are all solids. Think of dalda when you think about trans fats, and almost all of them are used for processed foods. We almost don't use it for cooking today. So we're going to concentrate more on saturated, unsaturated, which is mono, and poly. Now, how do these get converted to these. These are the fats in the diet and these are fats in the body. So the real core question we are asking is, what if I consume too much of saturated oils? What will happen to all these levels? What will happen to my LDL level? What will happen to my HDL level? What will happen to my VLDL levels? Vis-a-vis, if I consume monounsaturated fats, what happens to these? Versus if I consume polyunsaturated fats, what will happen to these? Let's try and compare some of this so that we understand, which are the ones which are beneficial to us. So the first here is kilomicrons. So all of these are converted into kilomicrons, and then it goes into the liver and forms some of these cells. So kilomicrons are formed in the gut. It's in the ileum or in the small intestine. So there is intestinal absorption, there is chylomicron formation. Chylomicrons, that is, which are fat rich, can't enter into bloodstream, right? That's because fat does not mix into water. It's water not insoluble. So it enters something called the lacteal system or the lymphatic system, and then gradually it will enter into the bloodstream, and so chylomicrons have a lipoprotein coat around it, and we won't go too much in the details. So chylomicrons circulate all over the body. They are much larger in size. They float on water, and they predominantly contain that fatty acid that we have consumed, right? So it supplies it to the regions which needs it, and then chylomicron remnants are then taken up by the liver, right? And we know after liver processes what it does. The liver, the dietary fat, this is what it does, right? So dietary fat basically is either converted into triglycerides or converted into cholesterol, or if you're on glucose deficient state, it will go towards acetyl-CoA formation and ATP, right? So what we really want to do, like I've said before, is cause this dietary fat to go in this green direction, right? And not in this cholesterol direction. So the three dietary fats that we have are SFA or saturated fatty acids, MUFA and PUFA. Now let's look at these one by one. So what does SFA do, or basically what does MUFA and what does PUFA do in the body? Especially important is when you're eating fried fatty foods, so which one should you prefer, this kind of boiling or this kind of frying, which is the oil that is the best one, is what we're really trying to ask. So let's look at ATP yield from some of these, right? So saturated fatty acids, like I said, it's going through the green tunnel into ATP formation. So a saturated fatty acid, which has 18 carbon atoms, will yield about, one molecule of saturated fatty acids will yield 120 ATP. When you compare that to glucose, that's only 32 ATP, right? So the body should ideally prefer fats, right, for when you're getting so much more ATP with just one molecule. But the problem is burning fat for fuel requires a lot of time, right? And it's not instant. And, like us and like our brains, the body also wants instant energy. So glucose can be burned instantly into energy. Therefore, we, crave more of glucose. But we want our body to go towards, fat metabolism and use fat as fuel. So saturated fatty acids will give 120 ATP, which is the maximum. Monounsaturated fatty acids like groundnut oil, the main fatty acid is oleic acid. It gives 118.5 ATP. And, one polyunsaturated fatty acid like sunflower oil, example, will give 114 ATP, right? So the winner here, of course, is saturated fatty acids, but only marginally, right? So if you consume saturated fatty acids or monounsaturated fatty acids, you pretty much get almost the same amount of ATP, whereas polyunsaturated fatty acid gives you much lower ATP. Right, so here we would actually prefer ghee over oils, right? Because saturated fatty acids like ghee, right? So ghee, if you are in a glucose deficient state, ghee will go through this and give you the maximum ATP. Then comes monounsaturated fatty acids, then comes polyunsaturated fatty acids. Now let's look at not only ghee, but what are the other sources of saturated fatty acids? So ghee and butter, like I said, but most animal fats and dairy are, and whatever is in solid state, remember, are saturated fatty acids, right? So ghee and butter, whole milk, cream, full fat dairy products, animal products such as, parts of, meat and fatty cuts, so the animal meat, which has fats is all again saturated fatty acids. Others like coconut oil, this is quite commonly used in many different parts of India like Kerala and Tamil Nadu and all. So, so coconut oil is also actually, quite solid at room temperature, right? So coconut oil is again an example of saturated fatty acids. Others are palm oil, kernel oil, and of course traditional festival sweets, like Diwali and other festivals, example laddus, halwa, gulab jamun and all of them have very high amounts of ghee, right? So this is all examples of saturated fatty acids. This will give you a lot of energy, especially when you are in a glucose deficient state. The problem here is when you consume too much of saturated fatty acids or ghee, it will raise your LDL cholesterol levels as well, right? So you'll the others don't do that as much. So you'll ask, how does that happen? That's because this is going towards TGs and then towards ATP and not going towards cholesterol. But the problem is saturated fatty acids will block or down-regulate LDL-C receptors on the liver. So the liver can't reabsorb the circulating LDL-C. So any excess LDL-C will remain in circulation, and that will, the numbers of LDL-C will go high. So if somebody is in a glucose deficient state and consuming a lot of ghee, then their LDL cholesterol is going to be high, and it is known to be a risk factor for cardiovascular disease. So if you can get away with an oil which does not raise your LDL levels, especially when a glucose deficient state, that is always better. Right, so then now we think about preferring oils over ghee. Right, that's because the oils don't do this. Right, so overall, if you look at the comparison, saturated fatty acids like ghee will give you the highest ATP, but it will increase LDL cholesterol. It will not affect TG much, and what it really does is LDL receptor activity down regulates, and therefore LDL can't be reabsorbed, and therefore LDL levels rise. Monounsaturated fatty acids, on the other hand, give you about 118.5 ATP. They decrease LDL and they increase LDL-C receptor functioning. Right? That's what they really are doing, and that's how they are, decreasing the LDL-C levels, and therefore they are cardioprotective. And polyunsaturated fatty acids, they strongly decrease LDL levels, they strongly decrease triglyceride levels, and they increase the LDL-C receptor activity, that is upregulation. Right? So looking at all of this, given the trade-offs between the energy and the LDL levels, we want to say that too much of ghee is perhaps not good. Groundnut oil or monounsaturated fatty acids are okay, but the best effect is now seen in polyunsaturated fatty acids. So before we conclude that these are the best ones, the next 3 minutes will tell you why they are not and why this can be sometimes spurious. So let's look at what is polyunsaturated fatty acids. So SFA becomes red now. That's because we don't want to use too much ghee for the fear of increasing your LDL cholesterol levels. Now let's look at PUFA, right? So what is PUFA? There are two forms of PUFA. One is omega-6 and the other is omega-3. Instead of telling you what are the ideal levels, what I am going to actually tell you is what is the ratio. The recommended ratio is, ideal is 1:1. If you consume 10 milligram of omega-6, you should consume 10 milligrams of omega-3 as well. But that is practically impossible, as you will see why. So, it's at least 4:1 should be the ratio. So if you are consuming, X amount of omega-3, you should be consuming 4X amount of omega-6. Right? So this is pretty much what, so far we know about PUFA. Now, what is this omega-6 and what is omega-3? I'm sure you've heard about these terms, especially omega-3, because there are capsules available, right? So, why you should take it. So let's try and understand this. Main examples of omega-6 is called linoleic acid and arachidonic acid, right? And omega-3 is 3 types, that is alpha-linoleic acid, EPA and DHA, which we'll see later on, right? So common dietary sources of omega-6 is sunflower oil, corn oil, soybean oil, rice bran oil, sesame oil, and a lot of processed snacks. So if you're thinking that you have sunflower oil for your cooking and you are doing a great job, you'll be mistaken, because as you'll see later on, it's perhaps not the best one, right? So these are the sources of fatty acid, omega-6. Well, sources of omega-3: flax seeds, chia seeds, walnuts, canola oil. So you perhaps are very happy that you consume flax seeds on a daily basis or chia seeds, but you will realize that the amount you're consuming is not enough, right? So these are seeds. Then you have a lot of these omega-3s in fish, such as salmon, sardines, and mackerel, and mostly fatty fish. So these are the ones which have omega-3. Stayed at room temperature, of course, these are polyunsaturated fatty acids. So these are, of course, liquids. And in the body, they are converted, omega-6 is converted into pro-inflammatory eicosanoids or states, right? So they increase the levels of prostaglandins. So this arachidonic acid is a precursor for something called prostaglandins, right? And leukotrienes. So these are the chemicals which circulate in your body, and they basically cause swelling all over the place inside, right? Not just obesity externally, but internally all your blood vessels are sort of in a swollen state, right? So too much of omega-6 in circulation that we saw before, when you eat an extra samosa and all those fats in your circulation, is perhaps more like omega-6. And swollen blood vessels will attract all these bad things, and you will start getting blocks. So they are inflammatory, whereas omega-3 is anti-inflammatory. It produces things called resolvins and protectins. Of course, the inflammatory potential is higher in omega-6, and omega-3 definitely is anti-inflammatory. So you'll realize that in the PUFA, Omega-3 is what we want. Omega-6 is not what we want, right? So the recommended ratio is at least 4:1, if not better, right? And omega-3, modern general diets, especially Indian and Western diets, have like 20:1 ratios of omega-6 to omega-3. We are consuming too much omega-6 and not enough omega-3. Right, so major health effects, of course, omega-6 can promote inflammation. Like I said, there is swelling all over inside, obesity, insulin resistance. Whereas omega-3, it supports brain function, it reduces inflammation, heart health, as well as fertility. Right, so metabolic pathways, we'll not go much into details, but just that these are broken down into inflammatory products, whereas omega-6 are broken down into anti-inflammatory products. Storage and use: omega-6 is stored in membranes and adipose tissue, and they are stored, around the fatty, in your tummy. What you're seeing really is the omega-6 from the PUFA. And omega-3 is incorporated into cell membranes, especially in the brain and the retina. So they are helping these organs function better. Supplemental need is not required at all in omega-6, because as you'll realize, almost everything that we have has some form of omega-6. Whereas omega-3, it is often recommended, because it's especially in vegetarian and in Indian diets. We'll see a little bit more. But in addition to this, what is more important is not the omega-6 much. We don't need so much omega-6. We need omega-3. So really the imbalance is the problem, not the absolute amounts of omega-6 and omega-3. Right? So we need to balance the two. Just to give you an example of some of the oils which have PUFA. So sunflower oil has 200:1 ratio of omega-6 to 3. Sunflower oil. So it's really high in omega-6. There is negligible omega-3. It's really bad for the body. Safflower oil has no omega-3 at all, right? Corn oil, 50:1, right? Soybean oil, it's quite difficult to procure, 7:1. Rice bran oil, 20:1. Sesame oil, 80 to 100 times is to 1. Right? So these are not the oils that we want to take, because we are causing pro-inflammatory states, obesity, and many other things. So PUFA with omega-6 is something that we do not want to have. So what we really want is high omega-3 and relatively low omega-6. Omega-3, like I said, are 3 types: ALA, EPA, and DHA. ALA is alpha-linoleic acid, docosahexaenoic acid, and DHA, which is docosahexaenoic acid. So ALA is really present in, it is essential, that is body can't make it, and it is mainly present in plants. But the ALA after absorption cannot be utilized much. It has to be converted into EPA and DHA, right? So only 5% of ALA that you consume is converted into EPA, and less than 1% gets converted into DHA. So if you're consuming only ALA, which is from plant sources, like flax seeds and all the others that we saw, you'll have to consume humongous amounts of ALA to get a very small amount of EPA and DHA, right? So that conversion is really important. So ALA or alpha-linoleic acid is plant-based, whereas EPA and DHA are marine-based, that is mainly fatty fish, as well as some algae. Common sources, like I said, are flax seeds, chia seeds, walnuts, and soyabeans, whereas EPA and DHA both are fatty fish, right? So that is mackerel and all of those, quite expensive. Absorption, ALA is absorbed, but then the conversion is very poor. So bioavailability, when it gets converted into EPA and DHA, is really poor. EPA and DHA are well absorbed, especially when the meal contains fat, and they are highly bioavailable to us. Daily requirement of ALA is 1 gram to 1.6 gram. That's a lot. That's 1,500 to 1,600 milligram. EPA and DHA both are roughly about 250 to 500 milligrams, each, right? So when you combine them, you could get about slightly more than 500 as well. And DHA, if you're taking it alone, you need about 200 to 300 milligram for ideal brain and eye health. So, the real problem is, even if you're eating 1000 milligrams of ALA, which is like 10 grams of walnut, which is quite a lot of walnut, you're really getting only 50 milligrams of EPA, whereas you need 1 gram, right? So you are really getting not even 10%. From plant sources, you cannot get omega-3. And for that matter, if you consume 100 grams of these fish, you would really barely reach about 200 milligrams of EPA and DHA. So you'll have to eat a lot of these fish on a daily basis, right? And they are all damn expensive as well, and then can get monotonous, right? So the problem is, in overall, the dietary omega-3 is very, very low. Not only in the Indian diet, but in most diets except for the Mediterranean diet, right? Most diets are lacking in omega-3 fatty acids, just like protein, right? So protein is not there in the Indian diet. The other big problem in Indian diets is it does not have omega-3. So you need supplementation. So, without supplementation of omega-3, it's very, very difficult, to get the omega-6 to omega-3 balance done. So this is the one that I take. Of course, there are no financial interests, and this is the Swiss Ulti Boost. It is 4x omega-3, and it's a combination of the two, and the bioavailable amount of omega here is about 800 milligrams, right? So this is something that you can look at, and then there are of course so many brands. So just make sure that combination of EPA and DHA should be at least 500 to 600 milligrams of elemental or the active ingredient. So here now we have looked at SFA not being that great in terms of LDL levels. PUFA is not really that great, right? That's because most PUFA that we eat are omega-6, but what we really need is omega-3. So using PUFA like sunflower oil or safflower oil to cook is perhaps not such a great idea, right? So here in summary, ghee gives about 120 ATP but raises LDL. Sunflower oil, it gives lower ATP, right? And all these effects of strong decrease in LDL and triglycerides and increase in LDL receptors is driven by omega-3 and not omega-6, right? So sunflower oil is perhaps not the best one. Now let's look at what is remaining, that is MUFA, right? So we don't want ghee. We perhaps want monounsaturated fatty acids or MUFA, and we definitely don't want sunflower oil. So we are narrowing down into the best oil being MUFA, right? Monounsaturated fatty acids. What are they? Right. So what is this MUFA and why should we, use it? Because, the main sources, especially in the Indian setting, is olive oil, groundnut oil, mustard oil, avocados, almonds. These are some of the things that we get now in India. It is an unsaturated and it contains one double bond and therefore it's liquid. Right, it's efficiently oxidized for ATP. If you remember the green arrows, the dietary fat goes into triglycerides and then towards acetyl-CoA and ATP. So it gives you 118.5 ATPs with one molecule. LDL cholesterol impact, it reduces LDL cholesterol. HDL, it maintains or slightly increases HDL, and all this is happening because the LDL receptor is being upregulated. Triglyceride, it has moderate reduction of the triglyceride levels, and it is roughly anti-inflammatory, definitely compared to PUFA, omega-6 and the SFAs. Also, it improves insulin sensitivity. The excess of MUFA is, the triglyceride which is formed is stored in subcutaneous fat. It's not visceral fat, so it's relatively easier to lose. It has low atherogenic potential. Its boiling point is quite high. That is about 200 to 220 degrees Celsius. For cold pressed oils, we'll come to that a little later, right? So it's therefore stable while cooking. So to compare, the MUFA have the best boil points amongst all the three. SFAs like ghee, of course, even if you keep it on the gas for a little while, it starts boiling, and then that starts getting caramelized. So ghee has a lower boiling point. PUFA have slightly higher boiling points, about 150. That is, non-processed or non-refined ones, and MUFA have even higher boil points, right? So cook in high heat like the Indian settings, MUFA definitely scores even there. Right? So stability in cooking, it is stable, better than PUFAs definitely. Oxidation risks is lower with MUFA and higher with SFAs, right? I mean, when you expose it to heat, and it's therefore ideal for general all sorts of cooking, sauteing, salads, intermittent fasting lifestyle, and all of these. So which are these oils? Peanut oil, mustard oil, canola oil, some of these which are available. So if you look at peanut oil, that it has about 50% of the peanut oil is, or groundnut oil really, is MUFA, but omega-3 to omega-6 ratio is about 30:1. We want it to be about 2 or 3:1. That would be the best. So it has high MUFA, it has low PUFA, but still that PUFA is relatively high. The other one is mustard oil. Right, so this is the real good one, or the the sort of gold standard for Indian cooking. It's very high in MUFA. It's excellent MUFA. It has a great omega-6 to omega-3 ratio. So mustard oil is something that we should definitely look at. Right, so these are two ones for the Indian setting which are great. For an international setting, canola oil, which is not very refined, not very processed, or cold pressed, is perhaps a great idea. Right, so again, it's very similar to mustard oil. It is a relatively balanced oil, and it has good omega-6 to 3 ratios. A lot of the commercially available ones are not that great, and we'll talk in a couple of minutes on that. And others are not really easily available. Fish oils really are not used for cooking, but are available as omega-3 boosting substitutes. So what is very important is, whatever oil you choose, they should be organic. That really means it should be not produced by genetic processing, or the crop that is used for making that groundnut or that mustard should not be genetically processed, should not be pesticided, right? So it's called GMP, so genetically modified and pesticide free. That is really organic, right? If you're producing it in mass scale, you have to do that. And the other is cold pressed, right? So cold pressed means you are not heating that seed, or you're not heating that initial product like the groundnut or the mustard to milk the oil out, right? So what you're doing is really grinding it slowly, and whatever trickles out is being used. Whereas the refining processes, they heat it or they use some solvents, and they extract it. So the routine process or refined oils, which are not cold pressed oils, the refined oils have problems with genetic mutations causing those crops to not be good, and therefore the oils to be problematic. They can have toxins, and all those oils can get oxidized when they are being manufactured, right? So something which we call extra virgin olive oil is nothing but cold pressed olive oil, really, right? So it is better to use organic, and this all pushes the cost considerably higher. But even if not organic, try and use cold pressed oils. Groundnut oil and mustard oil are great. I find mustard oil has, though I'm a Bengali, it has a very strong aroma to it, especially cold pressed ones or cold pressed ones. So peanut oil is relatively better in terms of the flavor it gets, and I would prefer either of these two are really, really good for Indian cooking. So to summarize again, the ghee gives the maximum ATP but has problems with LDL. Sunflower oil, PUFA definitely are not great, and all of these benefits that you're seeing is from omega-3, and it also gives the least amount of LDL. So why would we want to use it? The best ones would be groundnut or mustard oil. They have slightly lower ATP. It's a trade-off, but they cause lowering of the LDL because of increase in the LDL-C receptor, and we've seen this before, right? So the sort of the verdict is that MUFA are the best oils, and in the Indian setting, groundnut oil and mustard oils are perhaps MUFA or groundnut mustard, and we don't want sunflower or any of these other PUFA based oils. Something else which also drives your body towards the MUFA-like effects is really fasting. Triglycerides decrease, HDL decreases, LDL definitely decreases, insulin levels decrease, ketone levels increase, ApoB falls, right? So it's really important, and fasting is what gets you into the glucose deficient state that we started with, right? So if it's a glucose deficient state, only then will you get benefits of all these other pathways that we talked about. So remember this diagram, we want this dietary fat to go towards these and not towards this cholesterol and down, and that will happen only when you have low carb diet. Right, so it's really, really important to get into low glucose state and then force your body to get into fat burning or fat metabolism. And this is pretty much how you do it. This is the previous lecture, and I hope you're going to take a look at this because I talk about endogenous production of lipoproteins and what happens to all of these. I talk extensively about ApoB, LDL, and many other things. And of course, this is a video which is a must watch. It's about insulin resistance, and this is what is breaking us inside because we are consuming too much of carbohydrates. And I hope you're going to take a look at this video as well. And the other one is you can design your meals. It's not rocket science at all, right? So it should be low carb, it should be high protein, and it should be evidence-based food, right? So that high fat, your high protein, we know high fat really means high in MUFA or monounsaturated fatty acids. It's the overall taste like ghee. It's great for garnishing and for light cooking, but perhaps not for all the time cooking. Omega-3 supplementation is absolutely essential to maintain the balance between the omega-6 and the omega-3. Minimum PUFA is great, right, to maintain. So unsaturated fatty acids of omega-6 variety are also required for many bodily functions. So entirely giving it up is perhaps not a great idea. So can have some of them, but maintain that ratio. And remember that getting into fasted state will get you into the fat burning mode, and without fasting, all that we've talked about today may not materialize. So these are some of the important take home message. In the next one, what I'll cover really is lipid lowering drugs. So again, it's based on this same diagram that we have, and I'll tell you where the HMG co-reductase and where the other drugs act, and whether you should take them, and what are the pros and cons of each of them. So thank you so much for watching, and I hope you will subscribe to the channel if you haven't done it already. I hope you're finding this helpful. Let's keep the conversation going with your comments and queries below. Let me know how you like it, and let me know if you want any more health and nutrition topics.